Today we are going to see the problem arranging coins. You have n coins and you want to build a staircase with these coins. And staircase consists of k rows where the ith row exactly contains exactly one coins. That is, some coins will be given and you want to build a staircase with the help of these coins. A staircase consists of k rows means some number of rows where the ith row has only exactly I coins. For example, the first row contains only one coin. The second row contains only the two coins. Likewise, each row contains the coins which is the number of the row. And last row of the staircase may be incomplete because if you have these 5 coins and you want to arrange it in the by row wise, in the first row you arrange one coin. In the second row you arrange two coin. In the third row you may not contain 3 coins because there are only 5 coins you have. So in the third row we contain only 2 coins. So the final row must be incomplete, and we have to return the row with a zero index array. So we have to return the I minus 1 by setting I as 1. First row means 1, but we have to return the value as I minus 1 because here the third row is incomplete, but we return true 2 because third row is I minus 1. From the 0th index we compare it. So for that, what you have the logic is, first you have to initialize the count as n. So if you have, that is you are having your hand count as 5 coins, n coins, and you want to arrange by row by wise. For arranging in every row, you reduce a coin that is equal to the number of row. For the first row, you reduce the one coin from the count. For second row, you reduce the 2 coins from the previously updated count. Likewise, if you are reducing the coin by row wise, on the final row, you might get the count value as 0 because you initialize the n. You are reducing the count value by arranging in the row wise. For example, in this input 5, let count equal to 5 means, because I am storing in the count value as n. If you are arranging in the row wise means by setting I equal to 1, that is I equal to first row. For first row you reduce the count minus I, that means count minus 1, we have 4. On the second row, when I equal to 2, we reduce the count as 4 minus 2, that is 2. Now the count is 2. For the third row you have only 2 coins because you have only the 5 coins in this input. So from this third row you reduce the remaining coins also. That is, when count becomes less than or equal to 0, you might get as the value, the index value as I minus 1, that is a row. For example, third row means you return the value I minus 1. Like that you have to return the row when the coin is emptied by arranging in the staircase of each row. Let's code it in the online compiler. So int arranging coins. For that I have n coins. So I put n as input. I am initializing the count as n because I am having the n coins. That will be my count. I have to reduce it by arranging in a staircase. So for that I have initial row as 1, but you have to return as the 0 based index. Initial row as 1 while count greater than or equal to I, until the count greater than or equal to the I value, that is until the count becomes 0 or less than 0, I have to reduce the coins from the count by arranging in the every rows as exactly the I coins, that is ith row coin. So for that I am reducing as count from the count I am reducing a count minus I, that is count minus or equal to I, that is count equal to count minus I. From the count I reduce the I. For the first row it reduce one coin, for second row it reduce two coins, for third likewise it reduce by row wise, so I have to increment the I. For getting another rows also, when the count becomes 0 I have to return the index, that is return I minus 1, because I have to return as 0 based index. So now I put int n equal to 5 means here I have to give percentage d because the integer value, arranging coins of n. Let's see the output. Yeah, on the third row we arranged it, but we return the index value 2. For example, if I have 6 means that will be also returning the value 3. Oh. Let's check it on this Leetcode. It's completed. Sorry, we have written the number of rows which is completed. Oh, we have written the number of rows which is completed. Why I am setting this I equal to 1? Because normally if we have a coin, exactly one coin, we have the first row will be complete. I have to return the number of completed rows. Here the third final row is incomplete, so I have to return this number of rows, that is 2 rows only we have to that is completed. So that for that I have to return I minus 1. But in this 6 input we have 3 rows will be completed, so we return this I minus 1, that is equal to 3, because it goes to the when I for the fourth iteration when I equal to 4, that also will be run. When on that case we have count equal to 0, so for it will also run for the I equal to 4, so it return 4 minus 1 final iteration, so it return 3. So all the test cases passed.